Yes. Hello. Today I will be speaking to you about the go-mysql library, which is a library, of course, in Go, which you might have expected. And it deals with MySQL, which you might also have expected. I will first go over introduction, if the beamer likes it. Then I will go over some binlog handling with go-mysql, building a server, and building or like using the client. So who am I? I'm Daniël van Eeden. I'm working for PingCap on TidyB, which is a distributed database written in Go. And it's compatible with MySQL, of course. And I'm also a long-time MySQL user. And I'm also a contributor to many open source projects like Wireshark for the MySQL protocol decoding part, TidyB, MySQL, various parts, connector, server, documentation, whatnot. And I'm also maintaining DBD MySQL, which is the curl driver for MySQL. Today I'll demonstrate various use cases of the go-mysql library to you. This library was created by Sid Tang, which is the VP of engineering at PingCap. On GitHub, it's quite a popular library for dealing with MySQL things in Go. It's open source licensed. So that's how it started in 2014. There are quite a lot of things that are using this library. Sometimes it's a client, sometimes to deal with binary logs or other things. So some of these users are like Cache App, GitHub, Alibaba, YDB, and of course also PingCap. We use it as a part of our data migration toolkit. This helps you to migrate data from MySQL to TidyB. So that's also why I do this as part of my day job, not just as a volunteer. And there are like a lot more repositories using this library, so I think it's quite popular. The examples I will be giving you are made to fit on the slide, which is sometimes quite a bit of effort. Which means that error checking is left as exercise to the reader. That doesn't fit on the slide. And so is adding the right import statement. These are the basic things. So, like, let's concentrate on the actual part of the code that you're going to need. So go-mysql is a native Go library. It's not using any C or libMySQL client or anything. It's directly speaking the MySQL protocol and everything related to it, which also means you can like easily cross-compile it, etc. And there's no other dependencies that you need. And we don't depend on any of the MySQL client code, which is sometimes reverse, sometimes a benefit. First thing that we're talking about is replication. So of course MySQL does replication with binary logs. You're probably all familiar with this. It records changes. So of course read-only things you don't find in the binary log, so you don't get those. So for like an audit thing, it might not be sufficient, but to see what's happening with your data, it is definitely sufficient because this is where replication is built on top of for MySQL. And also point-in-time recovery. So as a library, we can request a stream of the binlog events from the server, just like we are, like if we were a MySQL replica. Of course, this requires the binary log to be enabled and requires the right permissions. Nothing special there. We recommend using the binlog format row. You can set it to statement-based. Then you just get statements out. We are handling it. But row is way easier to work with, especially if you then like want to handle it in some nice way. But you're not requiring it.
Does it also handle compressed logs?
Yeah, we are also handling compressed bin logs. And the other thing is like encrypted bin logs, I think are only encrypted on disk, but not encrypted when sent by the server. So that should also be working fine. There are a few other cases where we need to check things. Besides actually using the bin logs sent by the server as like a replication client, we can also read bin log files directly from this. But there are like encryption, etc., might not be supported. So this is the first example. So basically here, like we are setting up a listener for bin log events. We're saying like, well, connect to this server with this username without a password because we want to do things in a very insecure way. And then start streaming from like this binary log file with this position, just like you would do with MySQL. And then you're just getting events. And here we're checking only for row events, so all the other kinds of events we don't care about. And then we're just printing the first the value of the first column that we're getting, just as a demonstration. So this is how this looks like. On the slide, it doesn't look very nice, but the thing is, it just like gives you the configuration that it's working with. But then you can see that it starts to connect to the MySQL server. It's MySQL 9.2, and you get a set of values that were inserted. So that's the first part. Then we have a different API to also work with bin log files called Canal. And there you're defining a handler for events. And for this handler, we are defining on row that for every row we'll be calling this method. And then the method can do whatever it needs to do. And here we're also printing the first value of the first row. Same as the last example, but with a slightly different API. We are connected to a server, just like before. We say we're only interested in tables, in the table T. And this time we're not using a file name and position, but we're using a GTID because we are free to do either way. We support both MySQL and MariaDB GTIDs. They're completely different, which is really nice. But yeah, that's just how it is. Yeah, and then the output looks like this. So you get the value of the first column printed again.
And this is filtering the client on the client side. Any just events related to that?
Yes, it's getting the complete binary log stream and only filtering out things for that table, and only filtering out the row events.
It's a little weird that the filtering is side by side with the connection settings. There's a reason for?
Yeah, so one of the reasons is that this library, besides only doing the binary log tailing, it also can run a MySQL dump against your server to get all the information from the beginning. And that's why it might need this in the beginning in the same level as the configuration of your connection. Of course, you can also say like, well, I want all events, and later on I'm checking if it's the right table. That's also possible. Then we have another nice thing that you can use. It's a server. So here, go-mysql just tends to be a MySQL server. We are saying like, well, we are defining a handler And then for like the handle query, we then check, well, if the query is this string, then we're just sending this return set, result set. Yeah, we tell it to listen on a TCP port, accept connections, and then once it has a connection, it will pull the handle command thing for every command. And here you can see it's handle command, and on the top it's handle query, because there are many different kinds of commands. A query is just one kind of one command that's implemented. And this is how this looks like. You're connecting to a MySQL server. It identifies itself as 8011, but you can just configure the number. Yeah. If you want to say like 93, sure.
That has 970 LCS.
Yeah. It's a string, so it doesn't even have to be a number. I'm not sure what most clients will do if it's not a number, but
have you tried to use this as a honeypot?
I have not, but that might be a very interesting use case. Which I can sure see work. Yeah.
There's a honeypot specialist with us. We will talk about Sunday.
Yeah. So one of the things you see here is that like the select 2.2 plus 2 is 5. Yeah, you can just make it do whatever you want. But it does the query matching just over like if it's this string, this result set, it's not parsing the SQL for you. It's only implementing the server part. It's not implementing a parser. So this also means that if you type the select as like lowercase, it will not work. It's a different query. You can make it work, but yeah, it won't work.
Okay.
Another demo that didn't fit on the slide, I have a few. It's slightly more. I posted the code on GitHub if you're interested. So, another server implementation. So you do a create table, and you do an insert, and you do a select. It all seems to work as you would expect for MySQL. But then things change. That doesn't look like MySQL. It looks like SQLite. Yeah, that's true. So basically what I'm doing is this. I use the MySQL library to start a server. Then I get the query. I use the SQL driver in Go to just read this query to SQLite. And I get the result back. And I convert that a little bit and then push out the client. Worked quite well.
Is that using the database SQL drive?
Yes.
Are all the types supported?
It's a lot of work. Not yet.
When it comes to types, there is the interesting thing that basically, if you just pretend everything is a string, it works quite well. So in this example, I just have everything as a string. That really saves on all the time, and it kind of works in like almost all cases. So because the MySQL protocol is also kind of text-based in many places, so not many issues there. So if we use the database SQL library in Go, well, they can connect to SQLite, can also connect to Postgres. You just have a different connection string, and then you do this, like you do a generate series with like typecasting and all those kind of things. That also works. Another funny thing about implementing the server, in the code base, we also have a small example server where we have to implement a few queries because MySQL shell, when it connects, it expects a few queries to work, and otherwise it just crashes. So we implement the very minimum to actually be able to have a MySQL client and a MySQL shell being able to connect without crashing.
Did you follow up the rules?
I think I did. But that's also one of the things where this can help you to test various things, because normally a server never gives a zero result set on some of these queries. But this allows you to test all kinds of weird situations. So what's included is the MySQL protocol. We don't include any of the MySQL syntax. So you need to either build your own parser, which does not have to be SQL, by the way. It's just a query string. You can make it anything. And then as long as it returns a table-based result set, that's fine. Both TidyB and Vitesse have a parser, which I think is in both cases reusable. So that's one of the other building blocks you might want to use if you maybe want to have your own CSV-based storage engine or whatever. The other thing that's not included is the optimizer. How you execute the query is up to you. Also no storage engine, etc. It's just the network part of the server. Some of the use cases: security testing of clients, connectors, etc. Maybe honeypot as well. Education, just learning how a database server works, because with this you can build the really simple database server. It actually works with a regular database client. So if you just have your own hobby database server, you don't want to implement the network protocol, this works. Some experimentation for making other data available.
It could also be super useful to, in unit test of an application for simulating.
Yes, especially the less happy path ones. Then one of the other things that's in the go-mysql library is a driver. There's another slightly more popular driver from the go-SQL driver. It's also fine. It's just very similar. In many cases, you won't really see the difference. The connection string is different, but all the other things are probably more or less the same. And this is how you can use that. So you connect to a database, you execute a select version, and you get the version back. Nothing too special there. But another thing that we have is a low-level client that's not using the database SQL API, but it's just really standalone thing, which you can also use to execute the query and then get a result. And the result kind of looks the same. But we can do better with this library, because this library allows you to directly get the server version from the server handshake instead of having to send the query to the server. And this is just one of the many examples of the things that this allows you to do, which database SQL may not allow you to do. So the result is the same, but if you look at the network protocol, you see that you need less packets, less round trips. So
if you're running through a proxy, you might get different answers.
Yeah, sure. But maybe you need to know both versions, and then this works. And then one other demonstration, the last one. materialized views based on the go-mysql library. So I create a database test, then I create a table T and a table MG for materialized view. Then I start my code, and then I'm inserting some data into the T table. Then I'm looking at the materialized view table, and I get the average value of the things that I just inserted, which I can also directly get from the table, of course. But the thing is that if you look at the explain plan, you can see that one only needs to scan one row and the other two, which is fine for a small table. But if it's a large table, this is going to be quite a lot of difference. So basically what this is doing is it connects to a server, it gets current values of the table, then starts to tell the binary logs and keeps the total number of entries in the table, the total value, then it can calculate the average, and it's writing that back to the same server. So that is asynchronous, of course, but it might be enough for like some use cases. Yes, that's what you said.
How does this work if there's a join?
Sorry?
If there's a join in the view, T1, T2, here's a join between two tables?
Well, the events in the binary log should not really matter much if it's a join or not. So one of the other things is that, like in the binary logs, you get all the updates for every table, but you also get a marker when the transaction is committed. And only on transaction commit, I'm here updating the materialized view table. So if you're updating something with joining, that should also work with row-based replication. This doesn't work with non-row-based, of course. Thank you.
Does the application client part support acting as a same-sync client?
No, I don't think we do.
Have you tried to implement replication between MySQL and SQLite as like MySQL and SQLite segregated?
I haven't tried, but if you get all the events, you can kind of easily do that. But there are also quite a few other projects that do similar things where you get events from one thing, store it in like a Kafka stream, and then apply it in like whatever data source.
The Bayesian.
Yeah, the Belgium. But
Can you get the server version without needing to authenticate using your
no, I don't think we do. But yeah, you do get the server version in the very first packet.
Right.
But,
I'm thinking of this as it's a handy way to ping search rely-ish without actually needing to authenticate.
yes, yeah.
Another question, just want to show my support as well, and I appreciate from the library. You mentioned Ghost was using it without it would become Ghost. I proposed, nominated both the library and the author still on leave for contributor video. Continue to propose.
Thank you.
That's on low level API. Can you send different packets to the server and kind of mess up the normal order of the packet stream?
Yes. Okay. Any more? Thank you.
How does it compare to giving, for example?